So we have a plot here of IDS versus VDS for a single value of VGS. So this is the current with IDS is the current between the drain and the source, and VDS is the voltage between the drain and the source. And for a single value of VGS, the VGS is the voltage drop, the voltage between the gate and the source. So we have the MOSFET parameter here, the VTH or the what we call the uh, threshold voltage here is equal to 2. We have the electromobility is 0.5 times 10 to the negative 3. The unit here is the ampere per voltage square. So we have the VGS here, the gate source voltage. We have the overdrive voltage here, VGS minus VTH. And define ID for a linear region here. So the drain current here as a function of VDS is equal to Kn here is the Kn is the electromobility. So multiplied by the VGS minus VTH times VDS minus VDS squared divided by 2. They define ID for saturation region constant. So we have for the saturation, we have 1/2 of electromobility here. Then the difference between the VDS and VTH squared. So we have the piecewise function here. The piecewise function is uh, ID linear here of VDS. So the VDS here is then the what we call this overdrive voltage. So VDS is less than the overdrive voltage. Overdrive voltage. We call this the VOV is the overdrive voltage. Then we have the drain current here, saturation, this one. So the VDS here is greater than or greater than the voltage, overdrive voltage here. So we have the plot here of the drain current as a function of VDS here from 0 to 6 here. We have the plot range here, all style, thick axis level here. VDS for the x-axis VDS volts. We have the drain current here, the ampere. We have the plot label here, MOSFET IV characteristics, VGS equal to 5 volts. Okay, so this is our graph for these equations. So this is our equation for ID linear here. This is for the ID linear here. And we have for the saturation here. The saturation is given by 1/2 of the Kn. So Kn here is the Kn is the electromobility. Then multiply with the square of the difference between VGS and VTH. So VGS here is the gate. VGS is the gate south voltage, and VTH is the threshold voltage. And for the that's for multiple values of VGS here. So we have the same given here. VTH equal to 2. Kn is equal to 0.5 times 10 to the negative 3. So the unit here is ampere per volt squared. Then gate source voltage values 3, 4, 5, 6. So we have the 4 values of the gate source value, gate source values here 3, 4, 5, 6. So we have the drain current definition for each VGS. So the current here as a function of VDS and VGS. So we have the module here. So VOV is overdrive voltage. We call that overdrive voltage. So we have the overdrive voltage here. And we have the drain current saturated here. So the drain current saturated is 1/2 of Kn. So Kn is the electromobility. So multiplied by the square of the overdrive voltage. This is the overdrive voltage. So the piecewise here, so we have the Kn times the overdrive voltage times VDS minus the is VDS squared. This is the drain source voltage squared that divided by 2. So here the VDS here is greater than VOV. This is for the linear region here. So this is the linear region. This one. So this is also the linear region. This one. Now this is the saturation region. Okay. Then plot all curves here. Evaluate table of drain current here. VDS, VGS. So we have the VGS here. All values of VGS. 3, 4, 5, 6. And the VDS here is from 0 to 8. And plot range, all plot style thick. Axis level here, VDS falls here. And drain current here is ampere, this one. Plot level MOSFET output characteristic for multiple VGS values here. In plot legends here, place line legends to string at VGS values. So we have the VGS faults here, 3, 4, 5, the values of the VGS. So automatic here, grid lines, automatic.